So, dear students, today we will start the electrolytic conductance. The substance is normally divided in two types, that is electrolytes and non-electrolytes, depending upon conductivity of this substance in their aqueous solution. The electrolytic substances, when dissolved in water, it dissociates or it gives positive and negative ions and is responsible for conduction of electricity. While non-electrolytes, which when dissolved in aqueous solution, it not gives ions, and further it is not useful for conduction of electricity. If suppose we have NaCl, Na, it gives the ions Na plus Cl, and that ions, it means there is a dissociation of, okay, that means the separation of ions means the dissociation of ions. Okay, separation of ions means the dissociation of ions. If suppose a substance we take and which not dissociate into ions, that substance is considered as and which is not responsible for conduct the electricity is considered as a non-electrolyte. Okay, this substance gives the ions, and when you put the electrodes and batteries attached, then it can carry the current. Okay, the tendency of electrolyte to carry the current is called as conductivity. Okay, first thing we clear that what is meaning of electrolytes and non-electrolytes. Electrolytes, when dissolved in water, first things happen is the dissociation of ions, and which carry that ions, okay, that migration of, we will see the later, that migration of ions to the respective electrodes, so oppositely charged electrode will give the current, and that is the conductivity. Then electrolyte is classified into the strong electrolyte and the weak electrolyte. If suppose NaCl is a strong electrolyte, in a strong electrolyte, when it dissolves in aqueous solution, it dissociates almost completely. If suppose NaCl, when you dissolve in water, if 100 NaCl molecule is, you will obtain almost 100 Na plus ions and 100 Cl minus ions. Okay, totally dissociate, almost totally dissociation takes place. That electrolyte is called as a strong electrolyte. While weak electrolyte, okay, no doubt weak electrolyte is also gives the ions, but the number of ions given, okay, the extent of ions given is less. Therefore, the weak electrolyte we can define as it dissociate partially. For strong electrolyte, we have the example again, HCl is almost dissociate constant totally. HNO3, that acid is almost dissociate completely. NaOH it is always dissociate completely. That substances are called as the strong electrolyte, which dissociate almost completely. 100 molecule is there which dissociates completely, gives the ions. HCl gives the H plus and Cl minus ions, H plus and plus NO2, NO3 minus ions NaOH, Na plus and OH minus. Okay, like that there is a separation of ions takes place. Because that separation of ions, we have said that it is a dissociation of. Separation of ions is the dissociation of. Okay, there is a totally separation of ions, there is a totally dissociation of ions takes place in the strong electrolyte. While we have the weak electrolyte, that is the NH4OH. Okay, it is a weak electrolyte. Or acid CH3, acidic acid is also a weak electrolyte. We have defined weak electrolyte is a substance which not dissociate completely, it dissociate partially. Okay, partial means not 100%. Okay, if it extent is the 20%, 25%, 10%, like that there is a dissociation it takes place. Okay, suppose 100 molecule is CH3COH is there is a CH3COOH, 90 molecule remain as it is, but only 10 molecule gives the such kind of the ions. Okay, therefore it dissociate not completely. Dissociation completely means it gives the CH3CO minus and H plus ions almost 100. Okay, so it not in the form, combination form is not there. Okay, like that there is a fully dissociation. Okay, like that NaCl is a strong electrolyte, fully dissociated. It fully gives the 100 is there. It gives the 100 of NaCl molecule is dissociated there. Okay, therefore that is the again we have divided. So the first is the electrolyte. Electrolyte means the which gives the ions in its aqueous solution and which is responsible for conduction of the current, that is called as the weak electrolyte. And non-electrolyte means it not dissociates, it not give the ions in its aqueous solution and which is not is responsible for to carry the current, that is a non-electrolyte. And electrolyte is again divided into strong electrolyte and the weak electrolyte. Okay, next we have seen that the tendency of electrolyte to carry the current is called as the conductivity. Okay, tendency of electrolyte to carry current is called as conductivity. Okay, conductivity means to conduct. It means related to something conduct. The current is conducted or transferred via a solution is called as the electrolyte. Okay, suppose in normally when there is metal there is a current is flow via electrons. Okay, in solution also current is flow through its ions. Okay, that is positive ions and the negative equally. There will be, according to the Arrhenius theory, if there is a molecule A, B, it dissociate A plus and plus B minus. Okay, the positive charge and the negative charge are equal to each other and the solution is neutral. Okay, the total solution should be neutral because positive charge and negative dissociated positive and negative charge is always equal and ultimately it makes your solution neutral. Okay, and there is a equilibrium is there. Okay, always there is that arrow is okay for head arrow, back head arrow are the means that there is a equilibrium. Okay, if 10 molecules is dissociate, it gives the 10A plus and 10B minus. And if again 2 molecule is dissociate, again it's then again 2 this and 2 will combine gives the 10, the value of 10 remains constant. Okay, at that condition. Okay, if it gives the 2 again it gives the 2 dissociation, again the 2 will combine and gives the 10. Okay, the constant 10 will be remain there, that is will be equilibrium, and such kind there is a dissociation and your solution equally at the last neutral. Okay, conductivity is depends upon the types of electrolytes. conductivity is depends upon types of electrolyte. Types of electrolyte means the whether your electrolytes or whether your salt is a strong electrolyte or weak electrolyte. If strong electrolyte means what? The strong electrolyte means it dissociates almost completely. If there is a strong electrolyte, it dissociates almost completely. We have told that the number of ions produced by the electrolyte in aqueous solution is responsible for to carry the current. Therefore, the strong electrolyte, or the types of electrolyte means it is whether it is strong or weak. If strong electrolyte is there, it means number of ions produced by that electrode is more. Number of ions is responsible. Okay, more number of ions is there. That means it responsible for more current. Less ions is produced, it responsible for less current. Therefore, the strong electrolyte is there. It definitely carry the more current, and if there is a weak electrolyte, it means it definitely carry the less current. Okay, that first conductivity depends upon types of electrolytes. Okay, then concentration, it also depends upon concentration. Okay, if suppose in case of strong electrolyte, if you add the electrolytes more and more, it gives the ions more and more. And if you have the ions positive charge and negative charge more and more ions is there, therefore it gives the more and more. Okay, therefore you should remember that the more ions is responsible for ions, not more positive. Okay, positive and negative. When NaCl is there is definitely one is positive and one is negative. When more ions is there should be the more current. Okay, for the strong electrolyte, and less ions is less current. Okay, therefore the concentration is related to the strong electrolyte, because if you in weak electrolyte, as you increases the concentration, the dissociation is not increased. But in case of strong electrolyte, you increases your substances, then number of ions is increases, and number of ions increases, it responsible for to carry the current. That is the second point, concentration. When your concentration increases, the conductivity of electrolytes also increases. Then your third point is temperature. Okay, in case of metal, okay, in case of metal, when your temperature increases, the resistance is increases, because when you hit a metal, there is a random motion of electrons takes place. Okay, therefore random motion is there. Some is moving there, some is moving there. Therefore, it is having some kind of resistance is produces. Okay, therefore temperature, okay, it also depends upon the temperature. Okay, one of the factor is temperature. Is the temperature when you have the weak electrolyte, the tendency of weak electrolyte, when you increases the temperature, it's the dissociation. Okay, for weak electrolyte, dissociation of ions positive negative will goes on increasing as you increase the temperature. It is responsible for the weak electrolyte. When weak electrolyte is there, you increases the temperature, the dissociation is also increasing. Okay, therefore temperature is increases, the conductivity is increases in case of the weak electrolyte. Therefore ultimately temperature, it is opposite to the temperature is increases in metal, its conductivity is decreases. Okay, the next point is also depends upon mobility. Okay, that is velocity. Okay, velocity means the speed of the ions. Mobility of positive ions, okay, that is cation. Positive ions is called as the cations, and negative ions. Okay, it depends upon positive ions, and it also depends upon the negative ions. Okay, cation and the anion. Okay, like that way, the 4 points are the responsible for the carrying the current. Okay, now we will discuss how actually electrolyte is responsible for to carry the current. Is now we'll go to the discussing. Okay, suppose we have a electrolyte. Okay, electrolytic solution is there. Any solution, NaCl is there, it gives the Na plus and Cl minus, and which is responsible for to carry the current, that is electrolyte. And we have introduced a metal, two metals, and that two metals we have joined by a battery. Okay, joined by a battery. And if a small bulb is there, and when we join that battery, and if in this solution, if that solution is, if not possible, if you have the non-electrolyte, okay, in this, if you have the non-electrolyte battery, okay, battery is responsible for the, okay, one end is positive, other end is negative, positive and the negative. Okay, sorry, positive if suppose, and other end is the negative, positive and the negative. And the negative, that electrode is the cathode, we consider is a cathode, okay, one of the cathode, and that electrode is called as the anode. Okay, due to the positive charge, you will get the positive electrode, and negative charge, you get the negative electrodes. Okay, if in this solution, okay, there is a bulb is there, that, okay, for the sake of find out whether that solution carry the current or not, when you take the first non-electrolyte, any non-electrolyte, if you take the sucrose, okay, which is non-electrolyte, okay, and you add the battery, then current will start from there, okay, current will move in this case, okay, total your circuit will be should be completed, then current is moved like that, okay, current is there, but through this current is not possible to move because it is non-electrolyte, okay, there is no charges is there. If there is an electrolyte is there, then through the electrolytes your current is passed through this electrode, and through this electrode current is passed through the bulb, and a circuit is completed, and then this bulb will be produce the some light. Okay, but if non-electrolyte is there, that current is not possible. Okay, the electrolyte is responsible for to carry the current through the solution. Okay, if you take the electrolytes, it dissociates into ions. Okay, therefore it gets dissociated into your electrolytes is that. Okay, therefore it is responsible for to carry the current. Okay, at the one end is the battery negative, therefore that electrode is the negative and that electrode is the positive. And from positive end electrons is moving, you have the positive cation is there and negative anion is there. Okay, positive ions, negative, and number of positive and negative ions is there, because we have the electrolyte, and electrolyte has the tendency to produces the ions, it dissociates. Okay, that it gives the ions, means that there is a dissociation of ions. Okay, and then after the dissociation of ions, you will find that the electrons will come there, and that is negative charge, therefore positive charge will move to this negative end and will go to the dash electrode, and negative charge will go to the negative electrodes. Okay, therefore this will deposit, this will go there and takes the electrons and it get neutralizes, and this minus charge will go there and it will give the electrons to this electrode and it will move towards this side. Okay, electrons move through this wire. Positive will move towards it, strike on this electrode, falls on that electrode and takes the electrons, and the negative charge will move toward this electrodes and it gives the electrons, and electrons will be moved. Okay, like that, and your circuit will be completed. Okay, ultimately current is flow. Okay, therefore electrons current, your electrons flow is like that direction. Okay, through this direction electron flowing, okay, through the ions through this direction, and direction of current is always opposite to the movement of the electrons. Therefore current is moved through this direction and electron move to this direction. Okay, your current is move through anode. Okay, your current electrons will came to the electrolytes through this electrode, that is cathode, and electrons will be deposited or passes from the electrolyte is from the anode. Okay, such circle is the completed, and like that way current is flow in the through the electrolytes. Okay, now we will discuss the some points. Okay, this is all about the how the current is flow through these electrolytes. The specific resistance, one of the points we have to discuss. Okay, suppose we have a metal is there. Okay, that metal is there. Okay, the resistance of a metal is depends upon the two quantities as its length. Okay, its length. If suppose its length and is cross sectional area. Okay, this is a cross sectional area A. As you increases its length. Okay, if current is moved through this metal, as you increases the length, there is some resistance is there. Okay, as length is increases, resistance is also increases. Length increases. Through this length, resistance is increases, and the current electrons is moved. Therefore, that cross sectional area is if increases more and more, then the passage for the entering of the electrons increases more and more. Therefore, your length is increases, the resistance is increases, and your cross sectional is increases, the resistance is decreases. Okay, therefore resistance is directly proportional. Okay, length is increases, resistance is increases, and inversely proportional to the cross sectional area A. Cross sectional area is increases, therefore the passage for the electrons will be increases. Therefore, as your area is increases, okay, for the entering of the electrons, that is the cross sectional area is increases, then your resistance is decreases, because number of to home resistance to electrons, okay, resistance to the electrons, length is increases, your resistance is increases, cross sectional area is increases, the resistance is decreases, because more and more passage will be there your resistance is okay. If suppose small door is there and some people is go through the small door, if that small door is there, the resistance is more. If more door is the somehow bigger door is there, then people will move fastly. Okay, like that way resistance is increases with length and decreases with the area. Okay, by putting the proportionality constant, that is rho L upon A, that rho is nothing but the specific resistance. That rho is called as the specific resistance. Okay, that resistance is specific, limited. Remember, specific means that is the specific things. Okay, not for whole metal. Okay, that particular point, how many resistance is, that is the specific resistance. Okay, we will discuss later. You will get what is the meaning of rho. Therefore, by changing the rho will come there, then rho is equal to R A upon L. That specific resistance is equal to resistance into a cross sectional area upon length. Okay, then cross sectional area, that area is given by, okay, that area if it is cube, that is a centimeter into centimeter. Okay, then you will get its area. Area is given by the that length, and the height into the length is equal to your area. Therefore, a notation of the area, R is given in the form of ohm, resistance is given by in the ohm, area is centimeter square, and length is given by the centimeter. Okay, length is always measured in the centimeter, and area is there, that length into that length, two length is there. Okay, length into length, therefore centimeter into centimeter is there a centimeter square. Okay, therefore your area is the centimeter square. Therefore ohm is equal to, okay, sorry, rho is equal to ohm, centimeter is cancelled, therefore ohm centimeter. Therefore the specific resistance, okay, if it is 1 centimeter square, this is 1 okay, unit centimeter square, and your resistance is there. Okay, therefore resistance, okay, specific resistance, rho is the specific resistance, is the resistance for a 1 centimeter. Okay, resistance at 1 centimeter. Okay, if we have the metal carrying the current, and we'll take the slice of that length is the 1 centimeter and area is the 1 centimeter square. Therefore that resistance at that slice, okay, that at that particular 1 centimeter cube, or that particular 1 centimeter length, and the area, cross section area is the 1 centimeter. Okay, like that you obtain. Okay, therefore for that 1 centimeter your length and its area is the 1 centimeter square. Okay, that area is the 1 centimeter square. Okay, the resistance for this cube, or the resistance through a 1 centimeter distance and its area is the 1 centimeter square, that resistance is called as the specific resistance. Okay, its unit is like that, and the you can derive like that. Okay, now from the specific resistance, okay, specific resistance, because we have the formula, specific resistance is equal to R A upon L, and its unit is ohm centimeter. Okay, now the next term which arise from the specific resistance is the specific conductance. Okay, specific conductance is denoted by Ls, and it is nothing but the reciprocal of specific resistance. Okay, therefore its unit, if unit of the rho is, we know that ohm centimeter, therefore its reciprocal, therefore 1 upon ohm centimeter. Okay, therefore its unit will be m mho per centimeter, or ohm per centimeter. Okay, one and the same, mho or ohm per ohm, mho or the ohm inverse. Okay, like that, one and the same unit. That is called as the specific resistance, is nothing but the reciprocal of specific resistance. Okay, next their normal conductivity L. Okay, that is specific conductivity. Ls is the specific conductivity. Ls is the specific. Okay, that is specific conductivity means the opposite to the rho. Rho is related to the resistance. Ls is the resistance to the related to the conductivity. Therefore its definition is opposite to the rho. Therefore Ls can be defined, or specific conductivity can be defined as it is a conductivity per 1 cubic area conductor, or it is a conductivity of 1 centimeter length, and the cross sectional area 1 centimeter square. Okay, like that particular conductivity as the 1 conductivity. Okay, therefore you can define conductivity like that. Okay, the normal conductivity is also nothing but 1 upon R. Okay, Ls is the 1 upon rho, L upon L. Conductivity is the reciprocal of the resistance. Conductivity is nothing but the reciprocal of resistance. Okay, therefore it is equal to we can take this R is nothing but, okay, we have taken that R is equal to rho L upon A. Okay, rho L upon A. Therefore we will take R by putting the R, your EL will be at the bottom, rho L upon A. Okay, like that it is your conductivity. And then 1 upon rho is nothing but the Ls. Conductivity is the formula Ls into A upon L. Okay, that new formula you have obtained for the conductivity. Conductivity is equal to Ls A upon L. Okay, like that. Now that this is all about our specific resistance and the specific conductance. We have taken introduction of the electrolytic conductance. Thank you very much.